Okay, I will welcome you all for my next session on JK flip flop. Okay, so in this session we will be discussing about JK flip flop. JK flip flop. Okay, so here J and K stands for the name of the scientist who have discovered this flip flop. So the same way we will start with why this flip flop, then what is diagram or the circuit diagram or logic diagram. Okay, then we see the operation using this logic diagram. Then we will see about the extended truth table. Okay, extended truth table. Then we will see about what is the characteristic equation, and finally the excitation table. Okay, so first we will see why this JK flip flop. So when you talk about this SR flip flop, we have seen that there is one unused state in our SR flip flop. So one state, that is for your 1-1 condition, I am getting in unused state. Okay, so to make every state to be in a used condition, okay, that is to make all the combinations to produce desired results. Okay, we are going for this JK flip flop. Okay, in order to utilize all the states, that is 0 0 0 1 1 1 and 1 0. So for all the states it will get utilized. Okay, in order to utilize all these states, we are going for a new flip flop which is called as JK flip flop. Okay, so what is the structure of this JK flip flop? So the structure, if you see the structure of your JK flip flop, it is similar to your SR flip flop. So first we are going to make a cross coupled configuration. Okay, cross coupled configuration, and this will be your Qn, this will be your Qn bar, this will be your Qn plus 1 the whole bar, which is the next state, and this will be your Qn plus 1. Okay, and here one of the input is nothing but what? Qn bar, and here the input is nothing but Qn. Okay, and here I am going to connect to one OR gate. There is one more NOT gate. Okay, NOT gate, and we know that these two will be connected to a clock pulse. And here if I give the input as S and R, this will become your SR flip flop. Okay, this will become your SR flip flop. But here I am not going to give the input as a S and R. Instead of it, what I am going to do is this Qn, that is here I am going to take an output from the Qn. So this Qn is given as an input for your second gate 2. Okay, so now the input is what? Here Qn. And similarly, if you see, this is nothing but here Qn bar. So this Qn bar I am going to give as an input for here first gate. Okay, so one of the input is nothing but Qn bar. Clear? So now for input number, for the gate number 1, I have 3 inputs. One is here J, another is here clock pulse, which is very high always, and 1, and another input is Qn bar. Similarly for the gate number 3, K, that is gate number 2, there also there will be 3 inputs. Okay, one of the input is here K, another input is clock, another input is Qn. Okay, so now based on these 3 inputs only, my output from 1 or output from the 2 is going to depend. Okay, so now we will see what will happen when j and k will be in different inputs. Okay, so jk here also I am writing, and your present state qn. Now I want to determine the next state, that is qn plus 1, and if there are two inputs, we know that it may be either 0 0 0 1 and 1 0 or 1 1, and first I am not going to worry about the present state, that is qn. It can be either x. Okay, now we want to determine what will be my qn plus 1. Okay, what will be my qn plus 1? So first condition, we will go with j equal to 0 and k equal to 0. Okay, so both are 0 and 0. So I am going with the same color. So both are 0 and 0. Okay, so what will happen to the output at 1? So if one of the input is 1, one of the input for the gate number 1 is 0, another input is 1, another input is qn bar. So what will happen? If any one input is 0, automatically the entire output will become 0. So the complement will produce always as 1. So here also when the gate number 2, one of the input is 0 means irrespective of the other two inputs, automatically the output will become 0. So the complement will produce as 1. Okay, so the output of the gate number 1 is 1 and output of the gate number 2 is also 1. Now when you talk about the output of the gate number 3, that is qn plus 1. So qn plus 1 is nothing but what? So it is nothing but 1 into qn bar the whole bar. So which is nothing but qn. So now if you see, I am not getting any value at the top side. So I am going to the bottom side, that is qn plus 1 the whole bar. So at the bottom, what you are getting, at the bottom also I am getting the same thing, that is 1 into another input is qn the whole bar, which is nothing but qn bar. So what is happening here? So this is nothing but your present state and this is nothing but your next state. So next state is nothing but the present state. State is nothing but your present state. Okay, next state is nothing but my present state. So what you can the equation? So your qn plus 1 is nothing but qn plus 1 is nothing but your present state. So this will be nothing but your qn. Clear? So now I got your next state as your present state. Now for the next condition, that is j equal to 0 and k equal to 1. That is, if it is for the next condition, 0 1 condition, what will be my qn plus 1? So for to make it very clear, I am changing the color into a red color. Okay, I am changing the color into a red color. That is when j equal to 0 and k equal to 1. So what will happen? So at the top side, I have already told you, 0 multiplied with any of the other inputs, we no need to worry, output will be 0. So 0 complement will become 1. But at the bottom side, if you see, two inputs are 1 and 1. Another input is qn. So it is getting complemented. Okay, it is getting complemented. So first we will focus with the top part. Okay, so here what is the output? You will get 1 into qn. So qn will get complemented. So output will be qn bar. So now I am proceeding with the top side, that is qn plus 1. So to qn plus 1, what you will get? One of the input is 1, another input is qn bar the whole bar. So which is nothing but you will get the output here as qn. So I am not getting any output. So I am going to the bottom part. So bottom part is qn plus 1 the whole bar. So when you talk about the qn plus 1 the whole bar, one of the input is qn, but another input is qn bar the whole bar. So which means that what? It is nothing but 1. Because qn is 0 means qn bar will be 1. So automatically 0 into 1 is 0. 0 complement is 1. If I make your qn as 0, if I make your qn as 1, if your qn bar should be 0. Okay, so once again it will become 0. So 0 complement is nothing but you will get as 1. If this is 1, definitely your qn should be equivalent to 0. Okay, your qn should be definitely equivalent to 0. So for 0 1 condition, I am getting my output as what? It is nothing but 0 condition. Clear? So now we are moving to the next part. So next I am going to the next part, that is for 1 0 condition. What will happen when j equal to 1 and k equal to 0? So what will happen? So at the top side what you will get? I will get as 1 into 1 into qn bar. So 1 into 1 into qn bar, which is nothing but qn. At the bottom side it is 0 into anything. So 0 complement at the bottom side you will get as 1. Okay, at the bottom side you will get it as 1. So now we will proceed with the next state, that is when j equal to 1 and k equal to 0. K equal to 0. So your qn plus 1 is nothing but, and one of the input here is qn, other input is nothing but qn bar, the whole bar. So once again this will be 0 bar, so 1. So already I got your output at the top side. I don't want to proceed with your bottom side. I don't want to proceed with your bottom side. So when j equal to 1 and k equal to 0, my next state will be equivalent to 1 condition. My next state will be equivalent to 1 condition. Now I am going for the final condition. Okay, now I am going for your final condition. What is the final condition? That is j equal to 1 and k equal to 1. That is both are 1 and 1. What will happen? That is j equal to 1 and k equal to 1. Both are 1 and 1. At the top side what you will get? 1 into qn bar. So here at the top side you will get qn. Bottom side what you will get? Bottom also 1 into qn. So here you will get qn bar. Okay, qn bar. So both the things, it is something like you will get, if you talk about qn plus 1, here you will get your output as, here you will get the output as qn into qn bar, the whole bar. At the bottom side I will get the output as qn plus 1, the whole bar is nothing but same qn into qn bar, the whole bar. So both the things now you are getting the same operation. Both things now I am getting the same operation. So if the same operation repeats, what if same operation is going to repeat means what you want to do? Now I want to check it. So how we can check it? So now I am going to check with, I want to substitute your qn value. Now I am substituting qn as 0. So if I substitute qn as 0, what will happen? Your qn plus 1 equal to, so 0 into 1 complement, so the whole complement, which is nothing but 0 complement, so I will get as 1. Okay, now I will only proceed for your qn as 1. What will happen to qn as 1? If qn is 1, what will happen to your qn bar? Qn bar should be definitely equivalent to 0. Okay, so if this is on the 0, I will go at your bottom side now. Okay, so if I go with your on the bottom side what you will get? So qn into qn bar is on the 0. So once again this will be 0. If this is on the 0 complement, this will be 1. Okay, so when you are on the getting your qn plus 1, the whole bar is 1. Okay, when it is on the becoming on the 1, that is when qn equal to 0, my, if the present state is 0, the next state is becoming 1. Okay, if the present state is 1, okay, so which means that your qn plus 1 bar is becoming 1 means what will be my qn plus 1? So definitely this should be 0. So what is the next state you are getting here? 0. Okay, so if present state is on the 0, my next state is what? Next state is becoming 1. Okay, but if your present state is now becoming as 1 means what is happening to your next state? Next state is becoming 0. So what is occurring? It is becoming complemented. Okay, that is qn equal to 0. My next state qn plus 1 is 1 and qn equal to 1, if I say it means your next state is becoming 0. So 0 become 1, 1 become 0, which means that present state is complementing. So how I can want to write? Here you can write as qn and bar. Here this can be written as qn. So this is nothing but qn bar, which means that qn bar. Clear? So what is happening here now? If you see, if the inputs are 0 and 0, it is in the same state. Okay, that is your present state is on the retain, that is nothing but no change condition. Okay, so this is nothing but your complementary condition. Okay, so present state is complementing, so present state is complementing. So for 0 1 I am getting a reset on the condition, getting your set condition, I am getting my set condition. Clear? So now we want to draw the your excitation, that is extended truth table. Now I am going to draw your extended truth table. So how you will draw your extended truth table? I am having extended truth table. So one of the input is J, other input is K, another one is your present state, and we are going to talk about what is the next state. Okay, Qn plus 1. It may be either 0 0. If it is 0 0, present state can be also either 0 or 1. And for the 0 1 condition, present state can be either 0 1. And for 1 0 condition also, present state can be either 0 or 1. For 1 1 condition also, present state can be either 0 or 1. Now we want to check it. What will be my condition? Okay, that is inputs are 0 and 0, and the present state can be either 0 or 1. So what is happening? If the inputs are 0 and 0, whatever the present state is there, that is coming directly. So if it is 0, that will be 0 here, and if it is 1, that is coming as 1 here. So as per this truth table, you can see if it is 0 0, whatever the present state is there, that is coming directly. Okay, now if it is 0 and 1, if it is 0 and 1, what is happening? I am not going to worry about your on the present state. I am not going to worry about your present state. Your output is always becoming 0. So your output is always becoming 0 for 1 0 condition. So next is for your 1 0 condition. 1 0 condition also I am not going to worry about your present state. My next state is always becoming 1. So 1 0 condition, my next state is always becoming 1. But for this condition, that is the final condition, what is happening? If it is 1 1, and if it is 1 1, the present state is becoming complemented. So here what is the present state? Present state is nothing but 0. So this will become complement as 1. Here 1 is going to get complement as 0. Okay, so your present state is getting complemented. So this is the extended truth table for here. Extended truth table for here JK flip-flop. Okay, now using this on the truth table, now I want to write here characteristic equation. So now here if you see, it is a 3 variable function. Okay, characteristic equation. So 3 variable function. Okay, and characteristic equation from q of n plus 1. So what are the 3 inputs? So 3 inputs are nothing but one is jk, another is here qn. So jk I am writing here, one is qn. So qn can be either 0 or 1. jkn can be either 0 0, 0 1, 1 1, and 1 0. Okay, and 0 1 2 3. Okay, now we want to find where you got your output as 1 2 3 4. So now you got the one output in 4 location. What are the 4 location? If both the inputs are 0 0 and the present state is 1, both the inputs are on the 0 0 and the present state is 1, you get your output as 1. Next thing is what? Both the inputs are 1 0, present state is on the 0. Both the inputs are 1 0 and the present state is 0, and both the inputs are 1 0 and the present state is 1. And another one thing is both the inputs are 1 1, present state is 0. Both the inputs are 1 1 and the present state is 0. Okay, so now you got a structure like this way. So how you can group it? So here there are 2 pairs. One is this pair, another is this pair. Okay, so for this pair, what is the answer? So this pair, the answer will be nothing but J Qn dash, and for this pair the answer will be, which is common, K dash. So K dash into Qn. So once you write the finalized expression, Qn plus 1 equal to J into Qn dash plus K dash into Qn. So this is my next state condition or the characteristic equation. Next state or the characteristic equation. So this one now we can cross verify also. Okay, so how we can cross verify? For example, when I give here J as 0 and K as 1, and I am making my present state as 1. Okay, present state as 1. Already we know that when J is 0 and K is 0, okay, that is when J is 0, J is 0, K is 0, and present state is 1. What is the output you want to get? You want to get the output as 0. Okay, so now I will change the color for the better understanding. Okay, so when both are 1 and K equal to 1, it should become 0. Okay, so now substitute in this equation, that is Qn plus 1 equal to J into Q dash plus K dash into Qn. So K now it is on the 0, Qn dash means that is 1's complement, K is on the 1's complement, Qn equal to 1. So this is nothing but 0 into 0, 0. So 1 complement is 0, 0 into 1. So your output will be 0. So already we got the output as 0. So our equation is satisfying. Okay, our equation is satisfying. So for better understanding, I will remove this. Otherwise, okay, done. So now we want to go with our final thing, which is nothing but your excitation table. So already we told you what is called as an excitation table. Okay, so excitation table means based on my present state and the next state, that is Qn and Qn plus 1. Okay, Qn and Qn plus 1. We are going to set what will be the mandatory J and K inputs. And we already told you there are two present state and next statement. It can be either 0, 0, 0, 1, 1, 0 or 1, 1. So for this condition, what is the mandatory input? We want to check it. Okay, what is the mandatory input? We want to check it. So how to check the mandatory input? How to check the mandatory input? So where you got here 0, 0, you want to check it. So 0, 0. So I am getting in two locations. Here I am getting your present state is 0, 0. Here also I am getting your present state is 0, 0. The corresponding thing is here I am getting 0, 0. Corresponding input is 0. So if you see the J and K side, 0 remains say for the J, but for the K it is changing from 0 to 1, which means that is on the X. So J is on the 0, K will be nothing but X. Okay, so next with blue color, green color you will go. Okay, so next is 0, 1 condition, that is present state should be 0, next state should be 1. Okay, so here I am having your 0, 1 condition, and here also has 0, 1 condition, present state. So for that, what is the inputs? Here also 1, 0, here it is 1, 0, which means that J remains constant as 1, K is trying to change from 0 to 1, so K will be X, so J will be 1. So J remains on the constant as 1, whereas K is going to change from this to this. Clear? And next concept is what? 0 over 0, 0 over 0, 1 over then 1, 0 condition. So 1, 0 condition, where you will have here 1, 0 condition. we will go with one, which color? Blue color. We'll go with the blue color where you have the 1 0 condition. So here I am having on the 1 0 condition, and here also I have here 1 0 condition. So for 1 0 condition, what is the corresponding inputs? What is the corresponding inputs? So if you see the 1 0 condition, k remains constant as 1, but your j is going to change from 0 to 1. So for your j I will put as x, for the k remains constant as 1. Okay, k remains constant as 1. Then finally you are having here 1 1 condition. Okay, 1 1 condition. I will go with here yellow color. Okay, finally we are going with your 1 1 condition. So this is your 1 1 condition. Okay, so 1 1 condition, what will be the mandatory inputs? So for the 1 1 condition, if you see here also k remains constant as 0, but j is changing from 0 to 1. So k remains constant as on the 0, where your changes from 0 to 1, which means that is x. So here what is happening? 0 first in the SR we will mention first 3 bits, that is 0 1 0 directly, but here first 2 things, 0 will become 0 1 1, the rest 2 times you will mention as x, and you write in the opposite fashion. You write in your opposite fashion, you will get here excitation table. Okay, this is for the shortcut when you are writing your gate exam or some other thing. Okay, when you are preparing for some competitive exams. Okay, so once again we will have a glance on how we have started with this work. Okay, so when you talk about this JK flip-flop, so in the JK flip-flop it is an advancement of your SR on the flip-flop. So where in your SR flip-flop the condition 1 and 1 are not utilized, are being underutilized. So in order to make your 1 1 condition also to get utilized, we are going to design this JK flip-flop, where for the particular state 1 and 1 also I will be having a desired outputs. And when you see the circuit diagram of this JK flip-flop, it is the extension of here SR flip-flop. The only change what we are going to make here is, instead of connecting only feedback of Qn to third gate and Qn bar to the fourth number gate, we are making your Qn bar to be connected to both gate number 1 and 3. Similarly, Qn is connected as a feedback for the gate number 2 and 4. Okay, and since now there will be 3 inputs for the gate number 1 and 2, and based on the 3 inputs only the output of the gate number 1 and 2 will be determined. And one more thing what we will know about from this is, even though if it is 3 input or 4 input or 5 input, if one of the input is 0, then automatically the output of that NAND gate will be always 1. Similarly, whatever the input may be, if it is a NAND gate, if one of the input is 0, I don't want to worry about the other sets of input, so that always my output will be equivalent to 1. And when you draw the normal truth table operation, if for the 0 0 condition I am getting no change condition, which means that the next state is nothing but the present state. For 0 1 condition I am getting my reset condition, and for 1 0 condition I am getting my set condition, that is as 1, and for 1 1 condition the present state is getting complemented. So whatever the present state is there, that is going to get complement. Okay, so this is regarding the truth table. So the truth table I have only extended in the form of this thing. So before that I have only explained here what will happen when j equal to 0 and k equal to 0. Your present state is nothing but here on the next state. Okay, that is Qn plus 1 is nothing but here Qn, and Qn plus 1 the whole bar is nothing but here. Similarly, when j equal to 0 and k equal to 0, what is happening? So your next state is going to become 0 condition, and similarly 1 and 0 condition, your next state is going to become one condition, and for j equal to 1 and k equal to 1, what is happening in the next state means next state is becoming the complement of the present state. So how I have explained here, that is when I ask here we are going to assume it. So at the top part, if you propagate 0, it will be easily, you can calculate it. Already I told you if one of the input is 0, I can easily propagate it. So when qn equal to 0, I am propagating with respect to top part. So qn plus 1 will be 0 into anything complement, so you will get this output 1. For qn equal to 1, and I am on the propagating at the bottom side, such that I am making your qn as qn bar. So qn equal to 1 means definitely qn bar will be 0. I am propagating at the bottom side. So qn plus 1 the whole bar will become 0 complement 1. Okay, so if qn plus 1 the whole bar is 1 means definitely qn plus 1 should be equivalent to 0. Okay, so when this is becoming 1 to 0, when is making your when I am making your qn as 1. So when the inference what you are getting, when qn equal to 0, your qn plus 1 is becoming 1, and when qn equal to 1, your qn plus 1 is going to become 0. So 0 means 1 and 1 means 0, which means that your present state is becoming complemented. So we are on the writing one for 1 and 1 condition, your present state is getting complemented. So when you write the extended on the truth table, you will get an extended truth table what I have on the shown here. Okay, so based on the extended on the truth table, we have written the excitation table. So based on your present state and the next state, what will be the mandatory j and k inputs which will be used for mean conversion. And similarly, the characteristic equation has been also derived, which states that your next state is nothing but qj into qn dash plus k dash into qn. Okay, which can be also verified using one set of inputs. You can check for any set of inputs also. Okay, you can check for any sets of input also. For example, if I check for j equal to 1 and k equal to 1 and qn equal to 1, all are 1. So what will happen? Qn should get complemented. That is, I want to get your output as 0 here. So when you check here, what you will get j into qn dash plus k dash into qn 1 into 1 bar. 1 bar is 0, 0, and so k bar means 1. So what will get? 1 bar is 0, 0 plus anything 0, so you get your output as 0. Clear? So that's all regarding your JK flip-flop. We will see in our next section about our final flip-flop, which is also called as T flip-flop or toggle flip-flop. I thank you all once again for your passion listening.